Section 9 is about binomial distributions. So we need to first talk about what makes something a binomial experiment. A binomial experiment is a probability experiment that has these characteristics. So in order to be a binomial experiment, there have to be four things going on. Thing number one is that it has a fixed number of trials. So I'm going to flip a coin 17 times. It can't just be, what's the probability of getting heads on a coin? It has to be, what's the probability that I flip a coin 17 times and I get heads on the coin 3 times. Each trial has to have 2 possible outcomes. Now on a coin, that's easy to see. It's heads or tails, but that's really not what we're talking about. What we're talking about is that it is either a success or a failure. So if I'm trying to flip a coin and get heads, then a success is that it lands on heads, but a failure is that it lands on tails. If I'm rolling a number cube and I want to get a 3, then a success would be that I get a 3, but a failure would be that I get anything that's not a 3. Another characteristic is that the trials have to be independent, meaning that the probability of the second trial is not affected by the outcome of the first trial. And the last one is that the probability for success has to be the same for all trials. So let's look at this little formula right here. I wish it wasn't so small, but I'm going to label what all of these things mean. P of x means the probability of exactly x successes. So what we're doing here is we're repeating an experiment n times. So n is the number of times we do that. Each time you run the experiment, it has a probability of success p and a probability of failure q, which is 1 minus p. Then the probability of x successes in n trials is given by this formula. So p of x means the probability of x successes. This little teeny tiny n right here is the number of trials. Remember that x is still the number of successes. And that's the same thing as this x right here and this x right here. The number of trials n is this number right here again. P and Q are the probability of success and the probability of failure. So P, probability of success, and Q is the probability of failure. You know what I think I want to do is flip this to the back side, and I'm going to write that formula bigger so that I can explain it better, okay? So bear with me. Go to the back side of your page. That's times p to the x times q to the n minus x. x. Okay. So we'll break this down again. So P of x means the probability of x successes. NCX, we've done NCX before. Remember that NCX, the formula for that is n factorial divided by x factorial times n minus x factorial. So n is the number of trials. X is the number of successes. P in this formula is the probability of success. And we're raising that to a power. The power we're raising it to is the number of successes. And then Q is the probability of failure. And the way that we find Q is by taking 1 minus P. And then this exponent here of n minus x. N is the number of trials, x is the number of successes, so n minus x is the number of failures. So basically we're doing NCX times the probability of success raised to the number of successes times the probability of failure raised to the number of failures. So we'll run through several examples so you can see how these formulas work. We'll do this one here, and then we'll do, well, this one is all worked out, so we'll just run through this, and then I'll do another example over here before we move on. So the probability of 2 successes in 5 trials, where the probability of success for each trial is 0.2. So 2 successes, that's x. 5 trials, that's n. Probability for success in each trial, that's p. And since p is 0.2, that means q is 0.8. So they're going to take you through this, and they're going to do NCX, so 5C2, which was 5 factorial over 2 factorial times 5 minus 2 factorial, which is 3 factorial. When you work that out, you get 10. Finding Q, we already did, that's 0.8. And then to use our formula, it will be 5C2 times the number of successes, the probability of success raised to the number of successes. So 0.2 raised to the power of 2 times the probability of failure, 0.8, raised to the number of failures, which will be 3. And then when you work all of that out, you're going to end up with 0.2048. So the probability of 2 successes in 5 trials is about 20%. So off to the side over here, let's do an example. We are going to find the probability of rolling exactly 5 threes when you roll the dice 20 times. I guess it should just be die, because we're just going to roll one number cube. So let's figure out the numbers in this problem. X is the number of successes. So I want to roll exactly 5 threes when I roll the die 20 times. So X will be 5, number of successes. N is the number of trials, so that will be 20 trials. So I'm going to roll the die 20 times. I want 5 threes. P is the probability of success. So in this case, a success is that I roll a 3. The probability of that happening on a number cube is 1 out of 6. Q is the probability of failure. So if the probability for rolling a 3 is 1 out of 6, then the probability of failing to roll a 3 would be 5 out of 6. Then we're going to use our formula. Maybe I'll put the big formula up here. See if we can see all of that. If I cover up those words. Okay. So the probability of X successes, we're wanting 5 successes, will be equal to NCX, number of trials, 20, C, the number of successes, 5, times the probability of success, 1/6, raised to the power of the number of successes, which is 5, times the probability of failure, 5/6, raised to the power of the number of failures. Well, if there's 5 successes in 20 trials, that means there's 15 failures. So then we go through and figure out 20C5. So 20C5 would be 20 factorial divided by 5 factorial times 15 factorial. And then times 1/6 to the 5th times 5/6 to the 15. So that would be 20 times 19, 18, 17, 16. And then remember, I cancel off everything after 16. So 5, 4, 3, 2, 1 times 1/6 to the 5th times 5/6 to the 15. And then we're going to need the calculator because I don't know how to multiply all those numbers in my head. So we're going to do 20 times 19 times 18 times 17 times 16. Divide by, I can do parentheses, 5, 4, 3, 2, 1. So that number gives me 15504 times 1/6 to the 5th power times 5/6 to the 15th power. So you're going to have to kind of get good with working in your calculator on this, because we're going to want to multiply that, not on paper. So we're going to take 15504, and we can just type it in our calculator the way that we see it here. So times 1/6, which is 1 divided by 6, to the power of 5, enter, and then I'm going to do times parentheses 5/6 raised to the power of 15. What you should come up with is 0.129410292. You should definitely make sure you know how to make your calculator give you that number before you move on. So that comes out to be 12.94%. So the probability that I would roll exactly 5 threes when I roll the dice 20 times is 12.94%. Okay, let's do a couple more examples here. Find the probability of X successes in N trials for the given probability of success P on each trial. Round to the nearest tenth of a percent. So let's figure out all our numbers. They gave us X, N, and P, which means we need to figure out Q. Q is going to be 1 minus P, so 1 minus 0.4, so Q is 0.6. So in our formula, it's the probability of X successes. So we are looking at 7 successes. So the probability of 7 successes would be equal to NCX, so 9C7, times the probability of success, which was 0.4, raised to the number of successes, which was 7, times the probability of failure, 0.6, raised to the power of the number of failures. Well, if we have 9 trials and 7 successes, That means we have 2 failures. So 9C7 is 9 factorial over 2 factorial times 7 factorial times 0.4 to the 7 times 0.6 to the second, which would be 9 times 8 divided by 2 times 0.4 to the 7, 0.6 to the second. 9 times 8 divided by 2 is 36 times 0.4 to the 7, 0.6 to the second. And then we got to go to the calculator. 36 times 0.4 to the 7th times 0.6 to the second gives me 0.0212336664. And we need to raise that, around that, to the nearest tenth of a percent, so that would be 2.1%. Okay, next one here. We want the probability of 3 successes when we have 8 trials. P is 0.7, which means that Q is 1 minus 0.7, so 0.3. So the probability of 3 successes will be NCX, so 8C3 times the probability of success, which was 0.7, raised to the number of successes, which was 3, times the probability of failure, which was 0.3, raised to the number of failures. So we have 8 trials, 3 successes, which means we have 5 failures. So now it's just a matter of working through this. We have 8 factorial over 3 factorial, 5 factorial, times 0.7 cubed, 0.3 to the 5th. That 8 factorial, when I cancel off the 5, would be 8 times 7 times 6, divided by 3 times 2 times 1, and then I still have 0.7 to the 3rd, 0.3 to the 5th. So that's 56 times 0.7 to the 3rd times 0.3 to the 5th. Make sure you can do these in your calculator. I'm getting 0.04667544. If you're having a hard time getting the correct answer on your calculator, definitely make sure that you ask for help during class. So when I make that into a percent and round it to the nearest tenth, I get 4.7%. Okay, on to the back side. Now we have a story problem. A light fixture contains 6 light bulbs. With normal use, each bulb has an 82% chance of lasting for 2 years. What is the probability that all 6 bulbs last for 2 years? So in this problem, it's binomial because you have 2 outcomes. Success equals lasting 2 years. Failure equals does not last for 2 years. And they tell us that each bulb has an 82% chance of lasting for 2 years. So that means the probability for success is 0.82. And then the probability for failure, remember we do 1 minus 0.82, so that would be 0.18. Our light fixture contains 6 light bulbs, so that's our N. We have 6 light bulbs that we're wanting to know. And then in part A it says, what is the probability that all 6 bulbs last for 2 years? So that means that we're looking for 6 successes. So x equals 6. So our probability is, what is the probability of exactly 6 successes in 6 trials? So we've got 6C6 times the probability of success, which was 0.82, raised to the power of the number of successes, which was 6, times the probability of failure, which was 0.18, raised to the number of failures, which was 0. So we're doing 6C6, which means we have 6 factorial divided by 0 factorial, 6 factorial. Well, this works out to be 1 because the 6 and the 6 cancel, and so I have 1 factorial divided by 0 factorial, and 0 factorial is 1, so that is 1. And then we still have times 0.82 to the 6, times 0.18 to the 0, times 0.82 to the 6, times 0.18 to the 0. And you can just work that through in your calculator. So we have 1 times 0.82 to the 6th times 0.18 to the 0, and we get 0.30400666714. So the probability that all 6 of our light bulbs are going to last us 2 years is 30.4%. Now I want to know what is the probability that exactly 2 of the light bulbs will last for 2 years. So now exactly 2 of the light bulbs will be our number of successes, so x is 2. So within our formula, we're doing the probability of 2 successes. We still have 6 trials, so it will be 6C2 times probability of success is 0.82, raised to the number of successes, which is going to be 2 this time, times the probability of failure, which was 0.18, raised to the number of failures. So if 2 successes out of 6, then 4 are failures. And then we're going to work that through. So we have 6 factorial divided by 2 factorial, 4 factorial, times 0.82 squared, 0.18 to the 4th. So that will be 6 times 5 divided by 2 times 0.82 squared, 0.18 to the 4th. 6 times 5 divided by 2 is 15. So I'm just going to shortcut that a little bit and do 15 times 0.82 squared, and then that answer times 0.18 to the 4th, and I get that value, 0.010578788794. When I round that to the nearest tenth of a percent like I did the other one, I go 1, 2, 3. So I have, excuse me, I only go 2 places, 1, 2. So it will be a 1.1% probability that exactly 2 of the bulbs will last for 2 years. Because they are more likely to last for 2 years than to not last for 2 years. So the probability that only 2 of them will last 2 years and 4 of them will fail is going to be pretty low. Now this last question, this guy is a challenge. It's wanting to know what is the probability that at least 3 of the 6 bulbs will last for 2 years. This one's a little bit trickery because in asking for the probability that at least three will last for 2 years, our formula is for exactly 3, or exactly 2, or exactly 6. So the probability of at least 3 means that you could have 3 or 4 or 5 or 6. Now remember that in probabilities, when we have the word or, that means we are adding. So we are going to need to find the probability that 3 last plus the probability that 4 last, plus the probability that 5 last, plus the probability that 6 last. So this becomes a lot of work. The probability that exactly 3 last for 2 years will be 6C3 times probability of success 0.82 to the number of successes 3 times probability of failure 0.18 to the number of failures, which will be 3 in this case. And then we've got to work that all the way out to the end. So we've got 6C3, so 6 factorial over 3 factorial, 3 factorial. Which will be 6, 5, 4 over 3 times 2 times 1. Six, 5, 4 over 3, 2, 1 ends up being 20. So we've got 20 times 0.82 to the third times 0.18 to the third is 0.0643115635. Then we need to do the probability that 4 last. So probability that 4 last will be 6C4 times 0.82 to the 4 times 0.18 to the 2. And then we work all of that out. So 6 factorial over 2 factorial, 4 factorial times 0.82 to the fourth, 0.18 to the second. So 6 times 5 over 2. 6 times 5 divided by 2 is 15. So we're doing 15 times 0.82 to the 4 times 0.18 to the second. 0.21973111754. And then we need the probability that 5 are going to last that long. So that is 6C5 times 0.82 to the 5 successes times 0.18 to the 1 failure. So 6 factorial over 1 factorial, 5 factorial times 0.82 to the 5, 0.18 to the 1. So that's 6 over 1 times 0.82 to the 5, 0.18 to the 1. That's 0.40039900307. And then the probability of 6 successes, we already know from part A. So to figure out the probability that we have at least 3 of the 6 bulbs lasting for 2 years, we are going to add up all of these numbers. So we got 0.0643115635 plus 0.21973111754 plus 0.40039900307 plus 0.304066714. And what we're going to end up with is 0.98850. So that would be 98.9%.